So we're also introducing a new Ka band driver amplifier, CMD243. And this is another one in the series of, we pride ourselves on our amplifiers are very easy to use in that we don't need a negative supply for the great majority of our amplifiers. Right. So they're positive supply only. We don't have problems with sequencing, which is often a challenge with gas bars. Yeah, with a negative supply, or sometimes with even a positive supply part. Okay, what do I do about the VGG versus the VDD? Right. In what sequence, power up and power down you worry about. We don't have a problem with that. We have very robust designs that can handle VDD being applied with no VGG, or vice versa. So trying to make the designer's job easier is what we're trying to do. Understand their system needs, and then help them get their design done faster, but meet the performance requirements. So continue to focus on the performance.
What is the output capability of the drivers?
Drivers in the typical 20 dBm, P1 dB range for drivers. So those feed well into our power amplifiers that go up to about 5 watts. We have 3 gallium nitride power amplifiers currently, and doing some more work there in terms of the GaN space.
And are those mimics, the power amps, or are they single transistor?
No, full mimics, by self-bias. Two-stage self-biasing mimics, with the typical 28-volt supply.
Right.
And there, what we're up to is doing a GaN amplifier that is very good for communications applications.
Oh, okay.
So as opposed to a saturated, radar application, designing them specifically so they work well for high crest factor waveforms and the like. So we have very good AM to PM performance in our GaN power amplifiers. We have excuse me, we have characteristics of the devices we're using have the P1 dB to Psat difference is often a challenge.
Right.
You end up having to back way down if you've got a high crest factor waveform, and then you end up very inefficient. Your PAE goes way down. So our Psat to P1 dB is within about a dB across the whole band.
Okay.
And that allows you to run right up to saturation, remain efficient, or when you drop down to deal with the crest factor, you still get reasonable PAE. So that's part of the differentiation we're working towards in terms of using gallium nitride, which is a great technology, but using it for more than just an output stage of a base station or a radar amplification stage.
Right.
And similarly on the LNA side, we have 2 GaN LNAs, and
that's right.
They're very good LNAs, very good noise figure, high gain, reasonable power consumption, run down to 5 volts, but they also can handle 5 watts on their input.
Yeah. So that allows people to eliminate the limiter.
Eliminate the limiter, is what we're trying to help. Again, that helps the design, save size.
Right.
You have a very robust design quickly. So.
Yeah, so thank you for
your time. Thank you.